On April 12, 2016, during a science festival held in New York, world-renowned cosmologist Stephen Hawking made a stunning announcement. He introduced an ambitious and groundbreaking initiative called Breakthrough Starshot, a mission to search for extraterrestrial life. The plan? To send a spacecraft from Earth to another star system in search of life beyond our planet. The Starshot project was launched with the backing of Russian billionaire Yuri Milner. It also brought together the minds of Facebook founder and Meta CEO Mark Zuckerberg and the legendary physicist Stephen Hawking. An initial funding of $100 million was committed to the research, but full execution of the mission is expected to cost up to $10 billion. The ultimate goal of Starshot is to reach Proxima Centauri b, a planet orbiting the star Proxima Centauri in the Alpha Centauri system, located roughly 4 light-years or an astonishing 40 trillion kilometers away from Earth. To put that in perspective, even using the fastest spacecraft in human history, it would take approximately 114,000 years to reach it. Naturally, a journey of this scale renders traditional spaceflight methods nearly meaningless in human timeframes. To overcome this, the Starshot team proposed a radically different approach, the Starship. These tiny spacecrafts, traveling faster than Voyager, could potentially reach Proxima Centauri b in just 21 years. Once there, they would collect data about the planet and beam it back to Earth using laser pulses. The signal would take another 4 years to arrive, meaning the full mission could take anywhere from 40 to 50 years from now. But why go through all this effort and expense to reach Proxima Centauri b? The answer is simple. It's one of the most Earth-like exoplanets we've ever discovered. With a mass around 1.27 times that of Earth and orbiting a star. Much like our Sun, it sits in what's called the Goldilocks zone, where conditions could potentially support life. NASA's analysis suggests that Proxima Centauri b may indeed have the right conditions for living organisms to survive. For a planet to be habitable, it must meet many criteria. It should be a rocky planet of a certain size, possess liquid water, and have a stable atmosphere with the right pressure and composition. Though several such planets have been discovered, most are far too distant for detailed study. Proxima Centauri b, however, is located in the nearest star system to ours, making it the most promising candidate for life beyond Earth. Artists' impressions of Proxima Centauri b depict a planet strikingly similar to Earth. The only major difference, its sun, Proxima Centauri, appears much larger in the sky due to the planet's proximity. Still, realizing this vision comes with massive technological hurdles. First, the nanocrafts. Thousands of them must be developed. These spacecrafts must be incredibly lightweight, built with materials just a few hundred atoms thick, and capable of reflecting intense laser beams without being destroyed. Each Starship must also contain a miniature computer, camera, and communication system, all compacted into a few grams. Even then, the current level of miniaturization limits their functionality. They must also be durable enough to survive decades in space, enduring extreme acceleration, freezing temperatures, vacuum conditions, and collisions with space particles. Once these challenges are addressed, the project faces another task: building a 100-gigawatt laser array, equivalent to the output of a nuclear power plant, to launch these chips at incredible speeds. The lasers must be placed in dry, remote deserts to reduce atmospheric interference, and must precisely hit a 4-meter-wide target in deep space, all while accounting for Earth's rotation, orbit, and every other variable that could throw off aim. Given all this, it's estimated that it may take 20 to 30 years just to prepare the technology. Still, despite the difficulties, the Starshot project is seen as one of the most compelling missions ever proposed. Could it bring closure to our long-standing curiosity or serve as a bold new beginning? Many astronomers remain hopeful. Because space has no air resistance, once the nanocrafts are accelerated, they won't slow down. If everything goes according to plan, they could reach speeds up to 20% the speed of light. Even if just 1 out of 1,000 makes it, we may still receive valuable data within our lifetime. The current launch date is projected for 2036. If all goes well, humanity might receive the first ever images and data from an alien world sometime in the 2060s. Breakthrough Starshot, a mission more cinematic than a movie itself. When that day comes, will we finally find the answers we've been looking for? What will we discover on that unknown world? This was Midnight Journey,